All right, so here we are, section 1.2, starting off with a few definitions. A point is going to be something that has no dimension. There's no length, no width, no depth. It's usually represented by just a small dot. Right here we have a representation of that. Got point A, a small dot representing the point, and then a label of A for that. All right, a line extends in one dimension. It's usually represented by a straight line with two arrowheads to indicate that the line extends without end in two directions. So here we have representation of a line. And so we've got an arrowhead on each end saying that this line is going to continue in this direction and in this direction. It's going to continue in both directions forever. And then we have a couple of different ways that we can name that. We can name it as line L, because this cursive L here, lowercase l, represents that line, so it's line L. Or we can name it based on points that are on the line. So we got point A and point B. So we can do line AB. This is the symbol for line over AB, it's kind of the shorthand form. Instead of writing the word line, giving that symbol over the two letters, it would be line AB. Right, and then we can have a plane which extends in two dimensions. Right, so it's horizontally and vertically. Right, usually represented by a shape that looks like a tabletop or a wall. Right, the plane extends without end, even though the drawing of a plane appears to have edges. So whenever you see a plane like this, you have to imagine that there's like an arrowhead in every corner, so that it's stretching out in all directions forever, and that it's like a tabletop that just expands forever in all four directions. Right, so here we have 3 points in the plane, or we can have just a label for the plane. So capital M right here says plane M. There's not a point attached to it, so that's just a label for the plane. Or we can use 3 of the points. Points A, B, C would give us plane ABC. Right. Collinear points are going to be points that lie on the same line. So point A and B here on the same line would be collinear. Coplanar points are points that lie on the same plane. So in this picture, points A, B, and C would all be coplanar because they're all on the same plane. So here we have an example. We want to name 4 points that are coplanar. So 4 points that are on the same plane. So here's our plane in the diagram. So we got M, L, N, O, all on that plane. However, one thing that we can also try to envision is that this line, if these 3 points are on the plane, then that line is on the plane. And so just like this line extends forever this direction, this plane would extend forever in this direction as well. So L, M, N, O, and P, any combination of those would work here as points that are coplanar. And L, O, I'm going to throw P in there. Could also put M if we wanted to. All right, name 4 points that are not coplanar. So we need 4 points, and just one of those points has to be on a different plane. So if we use any of these 4, or technically these 5, they're all on the same plane. So the only point in this picture that's not on the same plane is Q. So as long as I put Q with 3 of these points, then it's going to be not coplanar. So let's go with M, P, O, and Q, making sure Q is in there, because otherwise all the other points are coplanar. And then name 3 points that are collinear. So 3 points on the same line. So we only have one line that has 3 points on it, L, N, O, P, any combination of those 4. So Ln and O, those would be all collinear points. All right, so then when we look at different types of figures we can create here, like line AB, just like we discussed before, shorthand form is a little line symbol, arrowhead on both ends over the two letters. So that would represent a figure like so, right? Point A, point B on a line together. All right, a line segment or segment AB, shorthand form would be AB with this line that doesn't have any arrowheads over it. Consists of the endpoints A and B and all points on line A, B that are between A and B. So point A, point B, and all the points in between would make up that line segment AB. Ray AB, or AB with a one-directional arrow on it, consists of the initial point A and all points on line AB that lie on the same side of A as point B. So point A is the initial point, that's where the ray starts, and it's going in the direction of B, so it's point A and every point that is on the same side as point B. So everything going this direction. Now whenever we name a ray, one thing we have to make sure of is that the first letter, when we say ray AB, that first letter has to be the initial point. So always make sure that the point where it starts is the first letter and a point that's on the arrow side is the second letter. If C is between A and B, then CA, or ray CA and ray CB are opposite rays. So you got point C in between point A and B, and so that means that the ray that starts at C and goes towards A would be an opposite ray to the ray that starts at C and goes through B. Okay. And really anytime that we have a set of opposite rays, it's just a line, but we've got multiple points on that line, so we can create different rays in different directions, or opposite rays in different directions, I should say. All right, so this example, draw three non-collinear points, J, K, and L. Then draw line JK, segment KL, and ray LJ. So what we want to do, following the instructions, is to start off by drawing three non-collinear points. So 3 points that are not in a straight line. So 1, 2, 3, something like that. Then we're going to label those J, K, and L. So now we're drawing line JK. So through J and K, we're going to make a straight line. Arrowheads on each end because it's a line. Then segment KL, that means we're going to connect point K and point L. I need to calibrate my thing a little bit here. All right, so K and L connected with a segment, so just the points connected by a segment in between them. And then we got ray LJ, so L is the first letter, so that's the initial point, and the arrow is going to go through J, so something like that. So JK is the line going all the way through, arrowheads on both ends. KL a segment, so it just connects the two dots basically. And then ray LJ starts at L and sends the arrow through J. All right, name two pairs of opposite rays in the figure. So in this figure here, anytime we have a point that's in between two other points on a line, we can identify the opposite rays. So we've got a couple of options here. If we use G as the initial point, we can have ray GE that would go with ray GH. Right, so G going through E, it's going to the left, G going through H, it's going to the right. So those would be a set of opposite rays. Or if we use F this time, F going through E could be one ray, and F going through G or F going through H could be another ray. So one set of opposite rays here, another set of opposite rays here. All right, when you have two or more geometric figures intersect if they have one or more points in common. So anytime that I have two figures that share at least one point, then we would say that they intersect. All right, so if I have two lines that share point A there, then we could say that those are intersecting lines, or point A is the intersection of those two lines. All right, the intersection of the figures is the set of points the figures have in common. So in this example, point A would be the only thing they have in common. Now, here we want to sketch a couple of different pictures or different types of intersections. We're going to have a line that intersects a plane in one point. All right, so we've got a plane, and we need a line that's going to intersect that plane in one point. So basically, it's kind of like a piece of paper and having an arrow going through a piece of paper. So draw it something like that. Drawing the dashed lines to represent what would be under the paper or under the plane where you really can't see it. And so it comes out here and it's coming out towards us here. You're going to have to kind of picture this three-dimensionally if you can. All right, so then this next one, sketch two planes that intersect in a line. And I didn't mention here, at that point where it hits the plane would be the intersection at one point. Now if we have two planes that intersect in a line, we're going to start with one plane here, and we're going to draw another plane that's intersecting that plane. And so dashed line here would be behind this part of this plane, so we wouldn't really be able to see that. And this dashed line would be under this plane here, so we really shouldn't be able to see that. And then the intersection is where those two are intersecting each other. And this intersection forms a line. So every point on this line would be part of the intersection. So that concludes notes for section 1.2.